Merry Christmas! Happy holidays, everyone. In this very special edition of the Code Review series, I think I may have found the first code that I've ever written. And by first code, I mean first code of an application, in this case a game, that actually works, that actually does its purpose. Not just like a snippet of code that goes nowhere. And yes, it is Java. So what we're gonna do today is we're just gonna go through this blast from the past and make a little bit of fun, just be a little bit roasty to baby Cherno. Maybe this will be a little bit relatable to some of you beginners out there, and I'll try and point out some issues with my code that will hopefully help you. So first of all, what even is this project? So this is a little game that I made called Squared. This is the original OG Squared, because I did actually try remaking this. I don't remember how far I got, like for a Ludum Dare further down the line, but this is the actual original one that I made. The concept is very simple. It's just this game where there are two squares, and it's actually multiplayer in the sense that it's just two players on a single keyboard. I think, yeah, the white square is controlled with the arrow keys, the teal square with the WASD keys. You have these abilities down here, which, if I remember correctly, were inspired by like League of Legends back in the day, just because that's what people were playing. And I made this game solely in English class because I was sitting next to a friend of mine, and like, you know, we were a little bit bored, and obviously we had our laptop. I think it was like 2011 or 2012, something like that. We had our laptops with us, and I just made a game that both of us could play together, you know, on a single keyboard. And I remember obviously it was a lot of fun to like work on this game, I guess, during that class, and then add features that we both came up with. And so yeah, this is basically what we developed. Now the whole point of this is just the teal square has to catch the white square. So if I move the teal square over here, maybe I should get my wife in here to play this. So let me explain how this game works. Basically, it's a two-player game, which is why you're here. It's on the same keyboard. One of us is this white square, one of us is this teal square. The teal square has to chase the white square. So it's like a game of tag. So basically you move around, I guess I'm teal. You move around, yes, you move the arrow keys. You move around with the arrow keys. But then where it gets interesting is you have these abilities over here. Stealth, speed, slow, and rage. You can discover on your own what they do. But that's the letter you have to press, like the key you have to press to activate the ability. I don't know, should I explain the abilities to you?
Well, I can read them.
So stealth, speed, slow, and rage. So stealth just makes you go invisible, see? And there's a cooldown for each ability.
How am I supposed to see myself?
You're not, but you can like, you should know roughly where you're planning to move. Mm-hmm. Also, it looks like you can leave, but you can't. Like you just kind of hide in the border, which is nice because then you can like pop out here.
Oh, right.
Yeah, strategy. Slow slows me down. So see, I get slowed down. And rage is cool. Rage makes you red, and that means that you tag me. So if you touch me, I lose. So like flips it, because I'm chasing you. Mm-hmm. And then I can grow. I can activate a shield, which doesn't look nice when you do it at the same time as growing. And then I can blink, which just jumps me through a wall. All right? Mm-hmm. So, ready?
Wait. I'm ready.
Yes.
Wait, stop this.
Oh, no.
Oh.
Wait, where's my blink?
I don't know what the...
Oh, no, I went the wrong way.
Stealth. How do I...
I can grow.
Wait.
Where
I don't even... I don't know.
Oh, I got you. You were right there.
Hold on. Rage.
Is that what you want?
Oh,
but I have a shield against your rage, see? So now if you touch me, it doesn't do anything.
Oh, I have to...
You have to survive for that timer.
I feel like I have a better chance at survival if I don't use the letters, because they slow me down by the time I find them.
That's because you're not a pro gamer.
So are you actually waiting for me to win?
Well, no, I don't think that will ever happen, but...
I don't know. Where are you? Why didn't it...
I went that way.
And I don't even know where I am.
No, because you're in the wall.
Oh, I can just stay there.
No, but I'll find you.
How? No, you won't.
Well, actually, there are coordinates over here which tell me where you are. And because I understand how numbers work.
Well, okay, go find me.
I won.
How?
Wait, I'm teal.
Yes.
Yeah, so I won.
But I was hiding.
Do you want to try a different map, a different board? I think they're all pretty bad. The first one's the best one. That's why it's first. Because like this one's just like, you know.
Didn't you make them?
Yeah, I did. Did I tell you this was like an English class?
During English
Yeah, during English class. This one's just dumb. It just switches randomly. You ran into me. I was still. See? Now I'm actually kind of stuck.
Ooh. Ah!
No. And then there's this one, which was, I think I was just experimenting with a moving piece of like geometry. So see, it can push you, which is kind of cool. Pretty technical, pretty cool. Pretty impressive actually for a 16-year-old to to do physics like this.
I think I have a strategy.
Where are you? Ah, there we go. All right, let's switch. No, use one hand. Use your left hand. I can move it close to you so it's more comfortable.
Left hand.
Left hand for WASD. Can't believe we have to go through this. And you remember like Minecraft? You played Minecraft.
Yeah,
before.
but I always use the arrow keys.
No, you can't use the arrow keys in Minecraft.
Minecraft?
It's WASD. Yeah, it's just been so long. All right, anyway. Yeah, so and then it's EQ and R. So they're actually over here, the keys. And there's only 3, so it's easier, hopefully, for you.
EQ and R.
Yeah, I gotta remember what
How
my
long
abilities are.
how long does the shield last?
Oh, you're chasing me.
Oh, wait.
So the shield is in case I use rage, basically. Like that.
Ooh,
Let's see how
oh,
long.
what? I did something good for once. Stop it!
So you gotta be careful. Because I can just,
Oh,
rage.
E.
Yeah. So see, now if I rage, you won't lose. But the thing is, rage has a really long cooldown. It's like 20 seconds because it's obviously good. So now you have a good 20 seconds because you can see how long I have left until I can use it again here. So you've got like a good window now where I definitely can't use rage. Oh no, that was so close. Enjoy your slowness.
Oh. There's literally no point.
I can go stealthy. Where am I gonna pop out of? Oh, there I am.
I don't even know where I am. Oh, wait, which
It's
one?
okay.
I'm teal.
The video ends when you win.
Are you serious?
Yes.
It's gonna be a long night. Like, I don't even know where I am. This is like...
It's okay, just look at the coordinates in the top right corner. Why did you use your shield?
do you think
What was the purpose?
I'm not looking where I'm...
Oh, I ran into you though, so that doesn't really count.
This is a bit embarrassing.
Yeah, I gotta survive for 20 more seconds.
This is embarrassing.
Wait, what?
I can't even get through the...
I thought it lost focus.
Oh,
yeah. That was actually so... My arm's like getting sore from this.
Can I use the arrow keys?
No, because not without some reprogramming.
I won. Just because
the time that I ran
did
into
something
you.
stupid doesn't mean...
I mean, I guess that's true.
Wish I could...
Okay. I didn't think you would clip over the wall.
Look at that.
Everyone, round of applause.
Okay, anyway, let's take a look at the code. So this is Java, I think it's either 1.6 or 1.7 or Java 6, Java 7. I was actually recently at a conference with a bunch of other developers and a lot of them were actually Java developers using like 20 something and they were like, Java has come a long way. So I don't know, people watching this video, have you experienced modern Java? Is it good? Because it's always fun to like talk trash to Java. And yes, I remember back in the day with Java 6 and 7, it was probably worthy of a lot of that, but maybe it's good now. I haven't personally used Java since like, I want to say since 2015-ish. So yeah, let me know if Java is good now. So if we go down here, I think we have the main function. All right. Oh man, this just is so nostalgic. Public static void main. You know, when back in the day, I feel like because I was programming so much and part of the way that I learned programming was I like to do like a lot of repetitive things, right? So in other words, there was a phase I remember where I would come back home from school in like, yeah, I must have been like 16 in year 2011. I'd come back home from school and I would just try and make something from scratch. And I had maybe like 3 hours to spend on this, but I would literally start a new project from scratch every single time. I don't know why. I think it's because I couldn't really get very far with that project. Hey, this is reminding me of my YouTube series, actually. Ugh. Maybe not much has changed. Anyway, I couldn't actually get very far with a project because obviously my knowledge back then was very, very limited, but I knew how to get like a basic window, a basic renderer, all of that up and running. And I guess I tried to see how much of that I could do like from memory. So every single time I'd come home and instead of continuing working on a project, I'd literally start it again. And I remember one of the ways I would test out new keyboards was like, I would just type in public static void main string args because that was like muscle memory pretty much just from writing so many Java programs. Isn't that crazy? Anyway, luckily for you though, there's a much better way to learn programming these days, such as Brilliant.org, the sponsor of this video. Now, Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. And it's the holiday season right now. And Brilliant have a 30-day free trial that you can use to explore their whole platform. Right, so why not spend some of this holiday free time and actually learn something? And Brilliant makes that super fun and effective. Take, for example, their computer science courses. They're really, really good to build a strong foundational base for computer science. They don't start with teaching you a specific language because that's not what matters. They teach you how to think like a programmer. And all of their courses are super visual, engaging, and interactive. They'll get you to actually drag things around to make these programs work so that you're not just watching videos as like a zombie, but you're actually putting it into practice. And that of course is a much better way to learn programming. And then all the skills that you learn there will lead into using an actual programming language like Python, which they, for example, have these AI courses for, which are super cool. But then you know what goes really well with programming? Math. Math is super important, and that is honestly where I think Brilliant excels. Anything from the beginning all the way up to things like calculus. Brilliant's amazing visual and engaging way of teaching translates into this beautifully. And as I mentioned, they have a 30-day free trial on at the moment. Just go to brilliant.org/thecherno. That link will be in the description below. Just give it a go, play around with their courses, see if you like it. And if you do, then that link will also get you 20% off an annual premium subscription. Huge thank you, as always, to brilliant.org for sponsoring this video. Anyway, those were the days. So what else do we have here? So the first thing we're doing here is actually making a new instance of this class, right? Because this is a static function inside the display class. If we want to actually use it as an instance, of course, we need to make it. Now you can see there's actually a commented out .getInstance here. So I was potentially trying to treat this as a singleton. I think that people who first start programming, at least this was my experience, and maybe if I had started with a language like C, it would be an entirely different story. But because I started with Java, and Java was an object-oriented language, everything had to be an object, and I really found that it was getting in the way of like my natural way of thinking. So how do you get around that? You just make lots of things static and singletons, because that means that they're just globally accessible. And for my ideas to come together in the way that I wanted to, I felt like objects and like, you know, hierarchies and all of that stuff were just getting in the way. Now, I had seen other programmers use these things, so I knew that they must be important. And remember, like, I'm 16 here and I've just started programming, so I have no idea what I'm doing. And by the way, this was not taught to me in high school at all. This was entirely self-learning. And in fact, at the time, there was no like physical person I could actually talk to about this stuff. Like I knew no one who knew programming. So really my only resource was like this Java for Dummies book that I bought and the internet. So classes and objects were seemingly important since everyone seemed to use them, but I just didn't figure out like why they even existed. And I often think about this. I think that universities jump into object-oriented programming way too soon. I think that if you pick a language like C++ and that's what you're teaching, since that lends itself to so many different styles and paradigms of programming, object-oriented programming should really be taught as just like, hey, by the way, you can do this if it makes sense for the case, but that's almost like an advanced topic. And really we should just start with making functions that work on data in the beginning, because I just think that's a much better way to go. I think I might need to make another C++ series. Anyway, I can also notice over here that, so there's display and display applet, and I'm guessing display applet, yeah, so this is an applet that I guess is deprecated these days, but this basically just enabled us to run this inside a web browser, which is pretty cool. But the main display class extends canvas, so it's a subclass of canvas, and it implements runnable. So canvas is just an element that you can add to a JFrame. So you can see we're creating a JFrame, which is just like a window in Java, and we're adding the game instance that we made here, which is the instance of this display class, we're adding it to the frame. And we can do that because this instance itself is actually a canvas, which is just something that we can draw to. It implements runnable just solely so that we can have this run function, right? That's what the runnable interface is. It has this like run function, right? And the reason why it has that is because if something is runnable, meaning it's like it implements this interface, so therefore it has that run function, you can make a thread out of it. So you can see we're creating a thread here from the current instance of the class, which means that when we start the thread, it's going to launch our run function on that new thread that we created. Now, why was this done? I believe this is just some kind of applet thing, maybe. I'm not really exactly sure why we create a dedicated thread to actually run the game instead of just running it on the main thread here, but that was just the design I was seeing, I guess, in other codes, so I followed it. Okay, up here in the display constructor, so this is the constructor of this class, and the display class is like the main class here, obviously. You can see what's happening is we're assigning, I guess, all of these objects that we have in the class to mostly singletons, except for render, which is set to render game. So input handler has an instance, player even has a static instance, and so does controller. Controller, I guess, has like this resource and then an input handler, and so this looks like it does nothing. It looks like it's a bit of a wrapper for this. It's a singleton because we've got the static instance over here, and then we have a resource. What is that? Okay, this is actually like, I guess, some sort of resource manager. So it lets us load resources, and we actually use it over here to create two static objects, the logo and the background. So I'm guessing this is this is probably the logo, and then that's the background, which I remember making that background in After Effects. That was fun. The After Effects like particle system or whatever, and then obviously like a radial blur. Oh man, this is nostalgic. So you can kind of see my approach to resource management here, right? Like there's no resource manager per se. There's just like these static buffered images, which are things that we can draw, and we just load them statically. And of course, this isn't hardware accelerated. Actually, the graphics API internally might be, but this buffered image thing is just something that has like, you know, an array of pixels basically. It's, as far as I'm aware, it's entirely CPU side. So of course, there's no issue, I guess, with initializing this here, because if we were using something like OpenGL or DirectX or Vulkan, we need to make sure that that was actually initialized properly, because in order to upload these textures and like create them on the GPU, obviously you have to have initialized that API first, which is why if we were doing this like on the GPU, we couldn't have them presumably as just static operations that happen before the main function. I'm actually not sure in Java if this does happen before the main function, if this happens when the class is first referenced and therefore it like loads that class and maybe it initializes the static stuff up the top. If that happens specifically in static startup before the main function, I don't think so though. Or if it even like happens the first time it's used, like a lazy loading thing, I don't think that's the case either. So if anyone wants to clarify like the order of operations as to like when these like static variables are actually initialized, leave a comment below. All right, anyway, and then we got, the input handler, which, yes, I remember I used to do this. It's so annoying. So this is interesting because this is fun Java. I mean, you have like this input handler that implements all of these listeners, right? So we've got like the mouse listener, mouse motion listener, key listener, focus listener, because we want all of these events to be received. And then what we do here is we actually add them all here. So this is kind of cool to me because like I make game engines, right? So I implement systems like these that are designed by me, because C++ like obviously doesn't have all of this stuff built in. You can use something like GLFW, which Hazel does use. However, GLFW doesn't have an event system the same way that like Java has this built in. So I build all of this myself on top of those existing libraries and frameworks. But Java provides this stuff out of the box. So it's just interesting to me to look at it and be like, okay, do I even like this design or is it weird? I think it's a bit weird with like all of these interfaces you have to implement. Java is a very object-oriented language, at least it was back then, so it makes sense. But anyway, since it does implement those interfaces, we then have to, I guess, add this input class instance as a listener to the canvas. So remember, where the display class, we extend the canvas. So we are like a canvas that we can draw to. And I think the canvas is like a component, yes. And I think being a component, it can receive events. And so what we're doing is basically, it's interesting this is happening inside this class. I guess it has to though, because we're trying to add these listeners to the canvas. But we're passing an input as the listener that we're adding, and then the input handler class is going to have all of these things, which you can see in Eclipse. By the way, I know I'm using Eclipse. I know that's like not really what people use for Java these days, and it's rubbish, and you should probably use something like IntelliJ IDEA. But this project was created in Eclipse, so it already had like an Eclipse workspace and all of like the metadata. So I just downloaded the latest Eclipse, opened it. I got to retarget it to like Java 7 or whatever. But anyway, that's why I'm using Eclipse, okay? I'm not a Java developer, I don't care. This little symbol here means that we're overriding, or like implementing, I guess in this case, an interface function. In fact, if I click on it, I think it'll take me, to here. So that's an interesting design. Not really how I do event systems. I just do it at like, I guess the function level. And that's really the beauty of using a language such as C++, which lets you do whatever you want rather than locking you into something like OOP. Because instead of creating a class instance that has all of these interfaces implemented so that I can create all these functions, I can just pass in like the functions directly, bind them to an event type, and then they just function as a callback that gets called whenever that event actually happens. Okay, and then you can see basically everything here again is static, which, you know, to an extent makes sense because there's only one mouse, like there's only one keyboard. Why have this be like not static in the sense that then I'd have to somehow track down the instance? What if I want to do it from many different classes? You know, is that bad design? Should I not be? The thing about making things static is that I think that it is really easy to obviously lead into bad design across your application, because it just means that it's globally accessible because it's public static, which means that suddenly I'm not locked into a specific place in my code where I can, for example, process input. Like if I want to make the player move when I press the W key, theoretically, I can do that
anywhere in my application. And the reason why that's bad is because as the code base grows and becomes more complicated and possibly even other developers work on it, that freedom unfortunately leads to like messy and bug prone code. Because if you have many different places where those keys are handled and they actually do something, then the code can kind of start fighting with each other, right? Like this happens in this function at this point in the application, like run loop, but then this happens later, which might override it. If it's not all inside one place and it's kind of processed in a very compartmentalized fashion, then you can quickly lose control. But this, of course, lends it to that. So the way that I would probably do this these days, I guess, is this would not be static, but I would want to somehow have like a central place maybe in my application, kind of like I do have here, where these are called, and instead of them just setting variables, like every time a key is pressed, for example, I might want an event to actually flow through the main class and into entities that care about those specific events, and they would subscribe to them. So I think that would be something I would do instead of this approach where what we're really doing is we're just basically receiving these events, but then we're just writing out, for example, when a key is pressed, we're grabbing the key code, and this is like just comedy here. but basically what we're doing is we have this like Boolean array of 65536 key codes, because like this is the max value of a 16-bit integer. I mean, I shouldn't say max value, it's the number of possible values for a 16-bit integer, because the max value is -1 if it's unsigned. But anyway, the point is we literally allocate, I guess, 65 kilobytes or so of memory here, 64 kilobytes, whatever, because for some reason we have to store this Boolean array of true and false for every single key. Now this is just ridiculous. So basically, if you're having trouble picturing this, it's like we have this huge array, right? And this is like index 0, index 1, index 2, index 3. And then if a key gets pressed that has like the key code 4, then we set this to true. But everything else here is going to be false, right? So it's like literally an array of true and false, and true is if the key is pressed and false is if it's not pressed. The reason why it's so large is because I believe key codes can actually go that big. So obviously if this was only like 128 and we get a key code that happens to be 50,000, then this will like crash with an array index out of bounds exception, because we're trying to write into the index of the array for that key code that doesn't exist. Again, ridiculous. I think if you really wanted to have like a set of keys that are pressed, then you could just use a set. For example, I mean, it's in the sentence. So like, man, I'm running some Java code. So I think you could do like set int or whatever, you know, pressed keys equals new, I think hash set, right? Int. And then what is it? I think it's like Control-Shift-O. I remember these shortcuts to import stuff. Oh, you can't do, can you not do this yet? I think you might have to write integer back in the day for this, which is hilarious. And then we can import set and hash set. Hey, I did it. Right, so we'd have writing some Java code. Beautiful. A horrible way to spend the holidays. Unless Java is good now. I don't know. Well, this version certainly isn't. All right, and then here, obviously, instead of this like true false rubbish, we would just be like pressed keys dot add, that's lowercase, key code, and then like pressed keys dot remove key code or something. I guess you might want to do like a contains first, just in case, so this doesn't crash. I don't know, that's like a possible way of handling this maybe, if you really wanted to have like a list of keys that are pressed. And then obviously you could query it by just being like, hey, does it contain this key code? And if it does, if it's in there, then it's technically pressed. Now the thing is, looking at these two methods on paper, like the thing that I would be worried about is just the fact that sets and like hash sets are obviously more intensive than just an array with an index. Like, yeah, this can look like a bit of a waste of memory. I mean, no one's really gonna miss that amount of memory, I hope. But it can look a little bit cumbersome or whatever. And this can certainly look much cleaner, but from like a CPU instructions to execute these things and how fast they would run, I'd probably put my money on the Boolean array, to be honest. I think the difference here is that it doesn't necessarily really matter. Like, I think the performance of either of these would probably be appropriate in the context of what we're actually doing with it. And this would technically be more stable, meaning that like, you know, if we do somehow encounter a key code, I don't even know if Java does this, but like maybe it's actually outside of this range, this would actually just flat out crash, right? But this can store any integer. So it's technically like safer. Now, another way you could do this as well, simply, is by storing these keys as bits instead of bytes. So a Boolean in Java, I actually don't know how big it is. I'm assuming it's a byte. All we're trying to store is obviously true or false, 0 or 1. So we can fit 8 of those into a single byte, not just 1. So that might also be a possible way that you can store this. And I guess you could maybe, because as long as 8 bytes, you could do something like new long
you know, if we want a 65536 divided by 8 or something. So 8 bits per byte, and then there's 8 in here, like 8 bytes in along. So you could do something like that. And so obviously that's going to be like a lot smaller. Okay, I think we spent too long on this, so I'm just going to remove all this. Back to display quickly. So this stuff we've kind of covered. Yeah, so player gets created with its instance. We have all of this stuff here. Beautiful. We'll get into that in a minute. And then we create this like render game thing, which implements render, which is an interface that I made. I don't know why. I think this was, again, just something that I was like, interfaces are a thing. I guess we should use them because they make our code look cool. So yeah, let's make an interface called render and then probably have a single class implementing it. Beautiful. And then you can see my beautiful state machine here. I kind of want to have a look before we dive into that, into how like the game loop works, and then we'll have a look at the meat of the classes. So we have this run loop, obviously, that gets dispatched and starts running when we start the thread, and this happens in game.start. So game.start starts the thread, which runs the run function on that new thread. We've got some like timing stuff going on here just to make sure that I think we run update and render in this case at 60 frames per second. A little bit of weird code here, but I think this is probably just nanoseconds per tick. So it would be like 1 billion or whatever divided by the frame rate, which is 60. And I think that would give you that. So 1 billion divided by 60. Yeah, that looks right. So that's where that number comes from. I just did that math instead of letting Java, I guess, do that math. And so once it accumulates, I guess, to being that amount, then we know that 16 milliseconds has passed and we can execute this. And the reason why it's set up like this inside a while loop is just in case the application is paused. It just ensures that we don't miss any ticks. I don't know if that's important for this game, but that was just the way I implemented it. So update and render both run at 60 frames per second, which is interesting. And then we just have this block here that runs once per second. So if this timer accumulates to over 1,000 milliseconds, then it runs and it adds another 1,000. So it runs again in 1,000 milliseconds, unless the game's been suspended, in which case it will catch up, I think, and run it every frame until it kind of catches up. And there's some actual gameplay stuff inside here, which is fun, like ability.countdown. So I guess certain abilities have countdowns, obviously, on cooldowns before you can use them again. So that's how we handle them here. We can just have this like static void countdown function that if anything is used, the cooldown is just decremented by 1, but that function runs once per second. So it works out. Okay, and then update and render will run player.update and controller.update. So controller.update does nothing, which is fun. So really player.update is the only thing that we run. And that's, I'm guessing, the meat of the game. And that runs freaking at this Cherno. That's why it's not working. Oh, we've got some stuff to explore here, guys. Yeah, so I think basically most of the game is implemented inside player, because obviously we don't actually seem to have any other entities or anything that gets updated apart from the player. So that's fun. And then render. So how do we render stuff to this canvas? Again, this is just like a standard Java boilerplate rendering to a canvas code. So I won't spend too long on this, but we just get the buffer strategy from the canvas. I'm guessing if it doesn't exist, we create it and return because we need to re-get it again. And maybe something has to happen between frames to do that. Then we just get the draw graphics from the buffer strategy, which is like our graphics rendering context that we can then render to. Then we have to dispose it and show the buffer strategy, I guess, every frame. The graphics class in Java is what we actually use to render this stuff. So if you see like the player being rendered as a square, let's see if we can quickly find that. So level.render, for example, yeah, you can see that there's that graphics object being passed in. I'm glad that this actually wasn't static and it's being passed in like this because it literally is like our graphics rendering context. So we set the color to a certain color and then we just fill rectangles. And I think that's basically how we draw everything. This is the level rendering class. So I'm just wondering like how we render, like, is there a player render? There's game.render. Yeah, so here it is. So there's that cyan player, right? That's like the one that we saw. And then we obviously have a white one as well, which is here. So gset color white, and then we do g.fillRect. The reason why there's so many conditions here is because abilities change things. So like the rage ability makes the player red, which means that it's the one that can catch teal instead of the other way around. And then player stealth hides the player. It's like stealth mode, right? So therefore we don't draw the player. But otherwise we fill the rectangle at the position with the size as well, and that's it. So you can kind of see how the rendering works. It's very simple, and obviously we're not even drawing textures apart from like the main menu, so it really is quite simple. Also, the cyan player has a shield, right? So if I quickly show you that, there's Q or E rather for shield here. So if I just press E, you can see it's like this like flickering shield. And the reason why that exists is because if this player is in rage mode, which makes him red, it can obviously catch teal, but if teal activates their shield, then it blocks that. So that's why that exists. And that's like the special condition for that, which we draw like an oval for. And we have this like XS mod 3, I guess, to draw it like once every 3 frames, and that's what creates that flickering effect. So that's the drawing. Again, very, very simple rendering. Pretty sure it's not GPU accelerated unless Java does that behind the scenes, which I don't know if it did back then. I think it's, I don't know, my memory is a little bit conflicted here, so maybe I should Google this, or you guys can help me out in the comments, but I do remember something about it actually being hardware accelerated if you're just drawing like squares and stuff using this graphics API. So I'm not sure if there's like some conditions that maybe you can enable that or whatever. Let me know in the comment section below. Okay, so then player update, as I mentioned, is where the majority of the game is. So let's actually focus on that gameplay code. So we have at the beginning a whole bunch of booleans. This is hilarious, but basically this is reading into that keys boolean array that we looked at in order to see what keys are pressed. And I'm guessing everything is processed within this function, so we just make it easy by being like, okay, well, what are the keys pressed? Let's just define them all at the very beginning instead of checking later on. And I guess the reason why I did this is because you can see that it adds information to them. If you just look at this means nothing. But ability AQ, I think A because it's player A and player B. So I guess the white player's Q ability is used. And I think the reason why I called the abilities QWER, I think that also maps to like League of Legends, which I'm just struggling to remember too much about. But you can see that this is kind of like the QWER, because in League of Legends, like I think those were like the ability keys, and they are actually those keys for teal. But obviously since you're sharing a keyboard, we mapped them to like L, P, O, and K here. So right up front of the update function, we just know if certain keys are pressed. Speed, if speed. I think speed is an ability. So yeah, so up the top over here in player, you can see we have a whole bunch of different abilities, and we just have booleans for whether or not they're activated, which is interesting. I'm surprised that I didn't separate out the players into like 2 different classes. I just kind of combined them into one class, which does make this a little bit messy, but I don't know, like honestly, I think it's okay. It may have been, even though this is a little bit OP, it may have been beneficial to actually make classes per abilities which have custom functions so that we could make the abilities a little bit more functional. In fact, I probably would do it that way. The reason why is because by having booleans like this for abilities inside the player class, you can see we have 2 as well for each ability. So can slow and slow. So can slow is whether or not they can use that ability, because obviously there's like a cooldown and it might already be used or whatever. And slow is whether or not they've actually activated that ability. But then it's not as simple as that, because if they have actually activated an ability like this, let's do a little search for slow, then you can see in the update function, we then need to have an if slow and an else here. And so what this does is if they're slowing down the other player, because that's one of the abilities, it subtracts like 0.15, I guess, from their speed every frame. And by the way, if you're wondering why there's no like multiply by time step or there's no delta time here, it's because we're running this update function at a fixed 60 times per second, right? So it's like a fixed update is basically what this is, and that's why we're not using time steps. So what happens with that design is that everything here is just like conditionals, and it's really not a great design. I think using basically state machines would probably be the correct way to do this, but I like implementing state machines through like actual functions that can get dispatched, whether that be through making, as I mentioned, abilities into separate classes which have like a certain on activate or can activate function built into them, or if they're just like implemented maybe in a language like C++, which allows you to just use pure functions and bind to them. Actually, you can do that to an extent, I think, in Java 8 onwards with lambdas, but the point is having that flow, I think, just cleans stuff up a lot, because whilst if statements or switch statements can make specific operations for certain states really easy in a simple context, as that begins to expand, and I would even say in this case where we have 7 abilities across the 2 players that can actually be used, it becomes not just messy to look at the code, but if you need to drill down into, okay, I want this to happen, but only in this context. Like what if multiple abilities are used? How do they stack on each other? You kind of end up creating all of these nested if statements, and it becomes quite bug prone just because you can't really see what you're doing clearly. I have mentioned this before, but I am planning to make a video where I show how we can better handle these things like using state machines and using functions. So that I think would be very beneficial in this case. But you know, when you're a beginner and you're just trying to get stuff working, I think this was part of the reason why this project was so probably meaningful to my programmer development journey, but also so fun, because I was just sitting there in English class, as I mentioned, which was like, I think a 2-hour class. I don't remember how many times a week. And of course I actually had to do English in the English class as well, right? This was just like oh, there's some downtime or whatever activity. The point is, I didn't really spend much time Googling things or trying to be like, what's the proper way to do this? I just gave it a go. I just said, okay, I need this to happen. Let me use the skills I've got to actually make it happen. And I think that's really special. I think that's something that maybe we're losing as there's so many resources online, but now there's AI as well that you can just be like, oh, I don't know how to do this. Like, can you do this for me? And even here's my code base. Please just add it. Like, that's rubbish, because going through the process of like, okay, I have a limited skill set, but let me use my mind to actually solve this problem. I think that's so important. It's vital to your development as a programmer. So if you don't do that at all, then I think that really, really handicaps you. So yeah, I encourage you guys who are learning programming to just put away the internet for a little bit, put away AI, put away whatever, and just be like, okay, I want to make this. I don't know how to make it work. Just like plan it out on paper and just implement it poorly. It doesn't matter. The point is you go through the process of making something work and solving that problem yourself. And that, I think, is just going to develop like that part of your brain that will really help you in the future. Okay, and then you can see, and this is like the issue as well. So we do have a class called ability, but we have functions within that per ability. So here's ability.java. This is a class called ability. And you can see again, all of this is like static. I don't know why exactly. I think it's just because I don't know. It's interesting because none of the functions are static, but this is all static. So like, for example, rage timer. I don't know. Let me do how do I do? I think it's like Control-Shift-G. Yes. Oh man. So I still remember the Eclipse shortcuts. Crazy. So yeah. So game render HUD. Okay. So we need to render how much time is left, like on the cooldown or on the actual ability being used. We need to render all of that stuff in the HUD, and that's all the way back in game when it actually renders like the UI. So this is also done using Java's graphics API. As you can see, here's like all the lines for the dividers between abilities, and then everything here. So yeah. So since we need to access that data, instead of providing it into this function, I guess through a parameter or whatever, it's just like make a static, make it work. Sure, like I don't know, I can't really blame myself too much on that, but yes, of course, much better ways to do that. So here's an ability actually being used. So if we go back to game, oh, it's not in game, it's in player. So if we actually run an ability over here, so you can see we actually do all of them. We're not even sure if they're used, but we still run the functions. So like, for example, a stealth ability, and then it checks to see if player can stealth. Then we actually set stealth to true, otherwise to false. So if the stealth timer, though, is above 0. So stealth timer is 0, meaning we're not currently using stealth. Just to give you a bit of context, so here's the ability called stealth. So if I press L, you can see I disappear. I'm still around. So if I press L, you can see, I guess the stealth timer goes above 0, which is why we can be like, it's used. So let's set stealth to true. And then once it, I guess, reaches. So this is again where a state machine would have been really useful, because you can have all these things like, for example, we're not stealthed, but then we can transition to being stealthed if, so this is like a little conditional transition, if, for example, the cooldown is 0. And then when we transition back to here, we can also obviously like run a function that like resets certain things. But in this case, it's all just if statements. And so I think what's happening here is that, see, I can't even see from here where can stealth doesn't even get set to true anywhere, does it? So now it's kind of like, okay, well, let's do a little search here to see, okay, reset abilities happens here. And then update. It's all like spread out as well. Can stealth get set to true if we actually press the stealth key already and the cooldown is less than 0, then can stealth is true, which takes us back into here and it says, oh, can stealth is true and the stealth timer, I guess, is above 0. So therefore, let's set stealth to true. And then I guess back in game, if stealth is true, then we don't do this because we only do that if stealth is false. So this kind of like being all over the place is definitely very error prone, and it's also slowing down the development. That's why I have that comment here that says freaking add this Cherno. That's why it's not working. Probably because I wanted to add like a new ability. Me and my friend would come up with like an idea. I'd add the new ability and it wouldn't work. And I'm like, oh, why isn't it working? Oh, because I didn't add it to here. So there's like so many different places where you have to add this stuff. It's not all in one place, which makes it so difficult. Kind of reminds me of adding a component in Hazel at the moment, where if you add a new component to the engine, you have to add it. There's like, let me actually find this. Okay, so here's components.h inside Hazel, and you can see there's this comment, adding a new component. If you add a new type of component, there are several pieces of code that need updating. There's literally like 8, bro. Like, this is crazy. A lot of this actually, I don't even know why this still exists, because we can actually iterate through all the components and just do certain things automatically. For example, if we need to create a prefab or duplicate something, then we don't need to manually add a new component type to that. But
this is bad, and this is something that, you know, should be avoided. So unfortunately, I seem not to have learned my lesson. I mean, you know, I'm not the only person who works on Hazel, but anyway, the point is, try not to do this. Try to, as much as possible, only have specific singular pieces of code that kind of branch out into the tree of that functionality, rather than having to manually go in and add so many different pieces of code in different areas of your code when you introduce something new. Let's look at like another ability. So like Rage, for example. Yeah, see, they're also all the same. Like, yeah, they have different countdowns, but this is another example of like, if I had just set this up as like a class, then yes, some abilities might have really specific functionality, which is why you can have those functions within the classes, like virtual functions, basically, that can get called and overridden if you need to implement custom behavior at certain kind of states or like areas of the pipeline of abilities. However, every single ability has this like, can it be used? Is it used? What's the cooldown? And how much is the duration of the ability being active? So if I just had that inside one class, then instead of having this duplicated per ability and said explicitly, I could have just had like an array, a map, maybe, I don't know, it doesn't really matter what the data structure is. I could just have like this collection of abilities, and internally they would just all have their variables set, and therefore it would just massively reduce this code duplication. Like, instead of it being duplicated 7 times per ability, you'd have one. You'd have one of each of these. You'd have one of these hidden within like the ability class. You'd have exactly one function, and then you would just iterate through all of them and do this decrement, which happens once per second to reduce the timers. And the reason why I didn't do that was definitely like just a skill issue. Like, definitely like I just didn't think of that because I didn't know that that was probably available to me because I wasn't experienced enough. So yeah, that's definitely, that would have been a huge improvement. Okay, we've got collision, we've got handle collision. This is really easy, just like 2 rectangles colliding. I actually think there's a really cool level. Was it 5? Yeah, which has this thing, which I think actually moves you, which is like super cool. So yeah, obviously no physics libraries here. There's a bit of a weird thing when it actually collapses on you, but I thought that was kind of cool. But yeah, like all this does, let's actually see where this is called from. So player update, obviously we move if those keys are pressed, and then we check to see if there's a collision. X, A, and Y are where we're trying to move to. They're like our delta. Actually, never mind. I think they're just A and B are for white and teal players, and the speed just gets added or subtracted for it. So this doesn't, okay, so this doesn't actually handle the collision. This just checks to see if it's true or false, whether or not we've collided already. But handle collision, this is so annoying if you look at this, because look, like these variables, so this is all in player. These variables are all like, I guess, members, like they're up here, you know, they're not passed in as parameters or whatever, which makes reading this function really hard. And I love this, like if that, and then return true, otherwise return false, because obviously you don't need any of that. You can just be like return that. But hey, I was a wee lad. There's also this fun thing where it looks a bit, so this is clipping the player to the game board, but you can see it's minus 32. And this is really cool because you can actually go exactly the size of the player out. So I'm gone, right? And then oh, I'm popping out here. That was a really cool game mechanic, because obviously if like you're being chased or whatever, you could kind of hide here and then pop out somewhere else and try and like lose, you know, whoever was chasing you. I think we kind of almost compare this to like hiding in the brushes or whatever in League of Legends. So yeah, that was kind of a cool mechanic. And that's why we have this over here to clip it to make sure we can't go past that. That's why it's not like 0. It's like specifically minus 32. And you can tell by this code as well that the origin of the players is actually the top left corner, because we're going minus 32 here, which is the size of the player. But here you can see we're just doing display.height and display.width, because obviously if this is the width and we're drawing from the top left corner, then if we're exactly at that value, we're completely out of the window. You can also tell that it's the top left corner, because if I use my size ability over here, you can see I'm growing from that. So I didn't bother centering it, which is kind of funny. Looks like we do actually have a concept of an entity and a list of entities, but is this maybe for the game board? We've also got like this bot, which just tries to move towards the player, I think. I made like a little level designer, which I don't think I actually, so if we've got our options, developer tools, level designer, I think you can like drag this around, but that's it. Like, I don't remember. I think the levels are made. We should have a little look at how the levels are made, but I'm pretty sure you can see that we just have this like render function, and then it's like if the level is 1, then call the level 1 function. If the level is 2, call the level 2 function. And so if we look at like level 1, you can see this is inside the render function, by the way. So it's being called every frame. We do place block at a certain position, which of course are all hard coded within the actual program. And then that sets the color to a certain color, obviously, and it just draws the rectangle. And if it's solid, then we do the calculate collision in here. Oh, this is interesting. Whoa, look at this, man. Oh, this is so interesting. So actually, the thing that determines the collision and actually modifies the player's position is actually coming from the code that renders the level. So if we go back really quick to this, so when this is being drawn, these white things, when it's being drawn, it runs a function that can actually move the player. Because I guess if this is a collision, it just moves it with it or something. So that is definitely wild. I'm guessing that took me ages to get right because it just seems so convoluted. But hey, I mean, I think it works pretty well. So I think that other code we were looking at was possibly like player-player collision, but this is actually player collision with the environment, because I was wondering how that happened because we weren't actually scanning the environment, like seeing what we actually have here, because all the blocks are basically contained within here. Oh, what are these arrays? XR. So level 3. Is it just in level 3? So these are random blocks. Oh yeah, this I think was just set up for level 3 because level 3 is this ridiculous level where it's literally random. And it changes, I think, every 5 seconds or something. See? So yeah, crazy. And yeah, you can see like level 4, which is this one over here, is, yeah, like these random shapes for some reason. How did the collision work with? Yeah, okay, you can't collide with a circle. Yeah, because that's separate. Otherwise, yeah, place block. And then if the block is solid, then we do a calculate collision on it when we draw it. Wow. So these functions do technically run after update, because if we go back here, we do update first, that's where we actually move the player. So that like XA and XB for both players, like their variables change inside update, and then render is where that basically gets conformed by the collision system, because rendering those blocks that make up the level is actually what adjusts that player position potentially if there is a collision to make sure there's not. So that is kind of cool. I don't think there's much else to really cover. I think this was for the level designer, but again, I didn't end up actually using it. Trying to work out, I think, how to like write stuff to disk and actually have it be organized like in some kind of serialization fashion. Yeah, I think we've pretty much gone through everything. It's clearly a very simple game, but I think the actual mechanics are cool, and it was definitely very fun to play. And yeah, there's that like blink ability. I remember this was from League of Legends, where you could just hit R and it would teleport you forward, so you can, in this case, get over walls and stuff. You know, I think what would be really cool is to remake this game in C++, make it actually multiplayer, like over a network, have it be like the base for covering all the things that I've promised to cover, like state machines, application architecture, multiplayer networking, ray tracing. We could make this 3D and ray traced, fully ray traced, instead of like rasterized graphics. Yeah, that's kind of a cool idea. And I could potentially do it fully on camera, like fully kind of like the Game Engine series, but hopefully the scope will be much lower. And maybe if I do like 2 to 3 hour episodes once a month, I'll get through it like within a year or something. That would be kind of cool. Let me know what you think of that in the comment section below. But anyway, I hope you guys enjoyed this code review. I hope you enjoyed revisiting the past with me and seeing this game. If you did, please don't forget to hit the like button. I hope you guys have a really good festive period and you get some rest for the new year. I'm looking forward to it. Lots of really exciting things to come. I will see you next time. Goodbye.